Welcome to the Statistic in ED YouTube channel. Today I'm excited to talk about magic in a twofold sense, in the sense of magic numbers that I will show you and in the sense of the magic of the purrr package. So I'm really keen to hear if you like this approach, this use case that I found. So the goal is to iterate over several vectors at once in R. It's a powerful tool to have in your toolbox, and it makes for very elegant functional programming. So let's have a look. What do we want to achieve today? So we're using the sample function to sample from the letters of the alphabet. It's a random function, and you can set the seed to make your code reproducible. And you see here on the left-hand side using the seeds 1 and 2 and sampling 5 letters from the alphabet and pasting them together. We don't get words back that make sense in the English language. So the seeds 1 and 2 are not very useful, but if we know the magic numbers, we may get more useful text back. So what we want to end up with in this video is the code on the right-hand side. I'm using the Pmap character function from the purrr package that we'll introduce in more detail in a few moments. We can iterate over 3 vectors, seeds, choices, and word lengths, apply a function magic message that I will show you in more detail, and the cat function just remove the quotation marks, and then knowing the right seeds that I will also show you, you don't see them here on this screen, we get a useful text back. It even rhymes, happy B-Day to you in 2022. So this is the code that we can, or the message, the magic message that we can generate when we know the right seeds. But we'll get there step by step. We'll start slowly and build up so that you can follow along, and let me know if you find this a powerful approach. So let's start slowly. We can manually build up words like you see on the left-hand side. And now I have 2 magic numbers here, a huge number, 1.9 million and something. And using that to draw 4 random letters from the alphabet and pasting them together, we get the word more back. And another magic number here, the second seed in the lower part of the code, gives us the word data back. So if we want to paste a longer message and build it up word by word like this, we would have a lot of redundancy. We would copy and paste the sample code and maybe just change the seed, maybe change the word length from time to time, but it's not a very nice coding style. We have copy and paste, which is error prone and hard to maintain in the long run. So we can do better. We do that on the right hand side. It's better to write a function in that case if we want to use some code part repeatedly. So I introduced the magic message function here. In this first version, it just uses one argument, the seed, and then it sets that seed and draws a random sample from the letters of the alphabet. And now below that function, you see how to apply it. I have a vector of 2 seeds, the same seeds that you see on the left-hand side, and I can use lapply to iterate over this vector of seeds and apply my magic message function. And this gives me, as a result, the text more data, a usual common wish in data analysis when you want to make better predictions, for example. Note that lapply always returns a list, so to get a more convenient output, I use the unlist function here. So this is the first version of our function, but we need to get better and more flexible. So here at the moment, we only iterate over 1 vector, the seeds. Let's introduce the purrr package. Purrr serves a similar purpose as base R's lapply that we just used on the previous slide. The basic function in purrr is called map, and it corresponds to lapply. It returns a list always like lapply, so it's very similar. But there are variants, map underscore, where you can specify a return data type. So for example, there's a map character function, a map integer function, map double, map logical, and so on, a couple of more functions. So we can apply these and have a look at the code on the right-hand side. We're not using lapply in combination with unlist anymore. I'm using the same code as before with the vector of seeds, and now lapply without the unlist function, and you see that I get a list back, which is not a very convenient data structure to work with for many use cases. So instead, we can use the purrr package, as you see in the highlighted code on the bottom right. We load the purrr package and then apply the map character function. So this time we don't get a list back, we get a character vector back directly. We don't need to use unlist. So it's a bit more concise and more convenient to work with than base R's lapply function. But the real power comes when we get more flexible with our function. So let's do that. We could say love is just a 4-letter word. So far our magic message function can only return 4-letter words. As you see in the highlighted code on the left-hand side, the number 4 is hard-coded into the function. So this is not very flexible. We can do better. We can become more flexible. So I do that on the right-hand side. And now word length is a second parameter in our function. And we pass this parameter to the size argument of base R's sample function. So that's the new version of our magic message function. It now takes 2 arguments, and on the next slide, we'll see how to apply this function. So we do that here. There's a convenient function in purrr called map2, and now it takes the following arguments: .x as a first vector, .y as a second vector, and .f a function to apply to the vectors. And then ... as a placeholder for more arguments that we can pass on to other functions. I have a special video about ... so you can check that out on my channel if you like. So we can apply this new magic message function now. We create these 2 vectors, the seeds and the word length, and now we can use different word lengths, so a 5-letter word and a 4-letter word, and I use the map2 underscore character function from purrr now to iterate over seeds and word lengths and apply the magic message function. And now we get the start of the message that we started the video with, happy B-Day. So this is an intermediate step. We're more flexible now. We can iterate over 2 vectors, but we're not there yet. We want to become more flexible yet. What if we had more than 2 vectors to iterate over? There's no map3 function in purrr, so we need to use a different approach. Before we do that, we have to add more flexibility to our magic message function. Remember the original message that we started with that even rhymes, happy B-Day to you in 2022. So we have a couple of words with random draws from the letters of the alphabet, but we also have this year 2022, this number. So the version that we had so far for magic message can only output letters. We changed that in the code on the right-hand side, and now the choices are also a function argument, the third argument. I put it in second place here in the order of appearance, we could say. So the choices are also a function argument now, and we pass this argument to base R's sample function here in the highlighted code. So now we have 3 function arguments, seed, choices, and word length. And how can we apply this new version of the magic message function? Well, now we can't use map2 anymore because we have 3 vectors, 3 function arguments to iterate over. So Pmap is a little bit different to map in map2. It doesn't have arguments .x and .y and maybe .z or something like that for the vectors to iterate over, but now it just takes one argument .l, which is a list of vectors, and then another argument .f for the function that we want to apply to this list of vectors, and the ... to pass on more arguments to functions. So how can we apply this Pmap function? We now prepare the 3 vectors that we need to create our magic message, the seeds, and now you see the magic numbers that we need for a message, the word lengths, which differ, and as the new and third argument, the choices. So the first 5 words are random samples from the letters of the alphabet, and the last word is that year 2022, so we pass it the digits from 0 to 9 as a list. So choices is a list, and now we can apply our magic function pmap underscore character, pass it the list of vectors, seeds, choices, and word lengths, and we just simply apply the magic message function that takes these 3 arguments and use the cat function to remove the quotation marks, and voila, here we are, we get our magic message, happy B-Day to you in 2022. So this is basically what I wanted to show you. I hope you liked this approach. Of course, this is a toy example. I hope you enjoyed it, talking about magic numbers, and magic functions. Of course, there are other use cases. One use case that I can think of is, for example, when you have files, maybe a large data set, and you want to create subsets of the data that you need to store. You may have several vectors, for example, filter criteria to apply to your data, and a vector of file names maybe, and then you have one function that filters the data and stores the data applying a specific file name. You could use the same approach that I showed you here, a Pmap function to generate these files without writing a for loop and without code redundancy. So a very elegant, powerful coding style, very few lines of code required to do a lot of work. I hope you liked that. That was basically it. You can learn more about the purrr package if you get the hang of it now. It's surprisingly badly documented for a tidyverse package. It's not part of core tidyverse, but it is part of tidyverse, so it gets installed alongside tidyverse, the meta package, but you need to load it separately with a call to library. And I heard from Bryan, who works for RStudio, on Twitter that the idea is to allow you to do basic data analysis steps without using purrr. But I think still it's a powerful tool to have in your toolbox, so it's worth finding out more about purrr. There's an RStudio cheat sheet that you can find in RStudio under Help, Cheat Sheets, List Manipulation with purrr. There's a chapter in the great R for Data Science book, or R4DS, about iteration. Bryan has prepared a tutorial on purrr, and she's also created a package, repurrrsive, with some nice data examples, nested lists, where purrr comes in very handy to deal with these data structures. Charlotte Wickham, Hadley Wickham's sister, has created a purrr tutorial, and there's a webinar on RStudio's resources that you can check out. And Colin Fay, who's so active in the R community, part-time editor of the R Weekly newsletter, and also creator and one of the authors of the great Golem package to create production-ready Shiny apps. He's also written a tutorial on how to use purrr. So have fun applying the purrr package. Enjoy. All the best for your R projects, your data analysis, your functional programming approaches. If you like the video, give it a thumbs up. Consider subscribing to the channel if you haven't already. Check out my other videos. All the best. See you next time. Ciao.